Intro. For a long time, astrophysicists thought it was completely impossible to look inside a black hole. But now, for the first time, researchers have been able to show that looking inside these black giants is possible. It is probably only a matter of time before we finally clarify what is really going on inside a black hole. Before we start with this exciting topic, we would like to ask you for your contribution. Leave us a comment after the video that fits the topic. If you are one of our subscribers, you'll always receive a heart and we will pin your important contribution at the top, where it will be read first by everyone. Just make sure you've already subscribed, like the video, and mention both at the beginning of your comment. Here we go with the mysterious giants of the universe. The mysteries of black holes. For a long time, there was only mathematical and physical theory. Albert Einstein, in his reflections on the logics and mechanisms of the universe, already came to the existence of completely collapsed objects of great size and extreme gravity. These results resulted from Einstein's equations of relativity and the interdependencies of forces. Einstein, however, did not yet coin the term black hole, which was invented spontaneously by the U.S. astronomer John Archibald Wheeler at Congress in 1967, because the scientist was tired of having to talk about completely collapsed objects of large size dozens of times within one lecture. Although the black holes existed mathematically on paper for a long time, Albert Einstein considered their real existence improbable throughout his lifetime. One could also say that Einstein did not trust his own calculations. He would probably have been happy about the discovery of the first real black hole in the cosmos, but this event took place only in 1971, and Einstein had already been dead for 16 years. The first black hole was discovered at a distance of 6,100 light-years from Earth in the constellation Cygnus. Nevertheless, nobody really saw this black hole at first. The existence could be proved through the measuring data of telescopes. Where black holes are, there suddenly appears a treacherous combination of an unbelievable mass with at the same time, seemingly empty round space. Meanwhile, we know about the existence of many thousands or even millions of these holes in the universe. Black holes are formed after supernova explosions. They are, so to speak, the relics of dead massive stars. If smaller stars of about 1.4 to 3 solar masses collapse, a fast-rotating and extremely radiating neutron star is formed. The final collapse of an extremely massive star, on the other hand, leaves behind the completely collapsed objects of large size first described by Einstein. Only their mass betrays them. When a star collapses, a very large amount of matter and light disappears in its place at a stroke. It's all the more puzzling that holes are left as relics of these dead stars, which seem to consist of nothing and yet have a large mass. The mechanisms behind these processes are one of the great mysteries of the universe. The gravity of a black hole curves the space so strongly that everything in the environment of the hole is attracted and then virtually plops into it. Matter that gets behind the event horizon of a black hole is inevitably sucked in and theoretically cannot escape from there. Now we know that black holes can suck up entire stars. They must be very spacious inside, or otherwise, they can dissolve matter by so far not known processes almost completely. Researchers used to assume that complete destruction takes place inside the holes. Thanks to quantum physics, we know meanwhile that a complete destruction of matter is not possible. The information from which it was once formed always remains. Even if a forest burns down, on the quantum level the information remains. Theoretically, one could rebuild the forest from this information. If a black hole now sucks in a nearby star with its gravitational pull, at least the information about this star must be preserved inside the hole. Objects from event horizon and singularity. A black hole most likely consists of a tiny center smaller than the smallest point you can imagine. These points are called singularities in physics. Singularity can also be called extremely condensed potential. In a singularity, according to the generally accepted formulas of relativity, the gravitational force moves toward infinity. In this case, infinity does not necessarily mean that the magnitude inside has no end. This value simply says that we cannot express with our numbers how high the value really is. Since black holes have an enormous expansion, there must be a sphere around the singularity. At its edge, the event horizon then emerges. Thanks to a lot of data and observations, scientists could get better and better at unraveling the mysteries of black holes. The more data and observations we have collected, the better we can reconstruct the processes inside these giants. Nevertheless, experimental physicists have said that it will probably never be possible to look inside a black hole and obtain precise measurement data. But quantum physicists see it quite differently. They say that it's now already possible to reconstruct the processes inside the holes so precisely from the quantum level that it would be like looking directly inside the hole. The behavior of quanta is practically the same everywhere on a certain level. One could also say that in the tiny volume of the singularity, the quantum processes take place which are described by the known quantum theories. According to some quantum models, values can be determined from the inside of the singularity which do not move towards infinity and therefore are not undetectable but deliver reliable data. If these considerations are correct, we should soon know more about which pressure prevails inside a black hole, which temperature and which physical processes take place there. What really happens inside a black hole? Until now, researchers assumed that an object that falls into a black hole is torn apart, crushed, and destroyed down to its information content at the latest after the collision with the singularity. The information content is practically a dimensionless and worthless state, a potential that is mysteriously preserved but has no mass and no form. In the 1970s, the German physicist Hans-Jürgen Seifert came to quite different results. Seifert could prove experimentally that matter which falls into a black hole can compress itself in such a way for a short time that singularities are formed. But in these events, no event horizon was formed in the experiment. In further experiments, it was found that this distinctive black hole identifier forms only when matter is preserved and flies around the singularity at the center of the hole instead of disappearing into it. This would theoretically mean that there is an incredibly large amount of matter in black holes. Perhaps this takes a state which we cannot describe scientifically at the moment. It becomes therefore really exciting. After all, some researchers assume even that black holes could be something like portals which lead matter from a dimension or a universe into another. The sound of black holes. So astrophysicists can now get closer and closer to the mysteries of black holes at the level of quantum mechanics and on the basis of simulations. Another approach to finally fully figure out what's going on inside black holes is to eavesdrop. Everything that is active in any way generates waves. These are not transmitted in the vacuum of interstellar space in the form of sound, but nevertheless we can perceive these wave emissions with special telescopes. Black holes have mass and thus exert pressure in space. At the same time, they are dynamic entities that radiate easily, and presumably most black holes also rotate. Consequently, pressure waves must emanate from these entities. The measurements are similar to someone looking at the pressure waves coming from your belly after you have eaten a portion of spaghetti. No sound will travel from the spaghetti itself to the outside, but the processes inside you will cause the expansion and pressure of your stomach area to change. The pressure waves that emanate from black holes are not in the audible range, of course, but they can be made audible. To do this, researchers raise the frequencies until they enter the audible range. This method is called sonification. In the case of the mysterious sounds of a black hole, the tones were raised a full 57 octaves so that humans could hear them. The sound sequence almost sounds a bit eerie. The sounds were recorded by the Chandra X-ray Observatory. X-ray astronomers catch an incredibly wide spectrum of waves emanating from every conceivable event in the cosmos. This allows scientists to study events and occurrences that are outside the visible realm. Many corners of the cosmos are far too dark to observe in detail with optical telescopes. Also with black holes, it is like this until today because hardly anyone has ever seen one. They appear merely as mysterious gaps, as masses in space, or as a faint glow emanating through the event horizon. First images of black holes. It's almost unbelievable that we know so much about objects in space that we can't actually see. Until 3 years ago, not even astrophysicists ever saw a black hole with their own eyes. See these monsters in books, in publications of NASA, or also with us. It concerns almost always graphic representations but no original photos. In 2019 the time finally came. Scientists surprised astro fans around the world with these images of the black hole at the center of the galaxy M87, some 55 million light-years away. Finally, in 2022, a photo of the black hole at the center of our own galaxy followed. This unique image of the black hole named Sagittarius A** was made possible by observations with the Event Horizon Telescope. The project is a collaboration of 8 radio observatories on 4 continents. The name, Event Horizon Telescope, already reveals that this super telescope has the ability to optically penetrate to the event horizon of a black hole. Strictly speaking, the hole itself is not visible on these images. The object becomes visible only by the brightly shining ring which develops by extremely heated up matter in the environment of the black hole. And so what do you think? Does this sound to you like scientists will finally be able to see inside black holes? Or do you think we're more likely to be in the dark for quite some time before we understand what black holes really are? Let us know and share your thoughts with us in the comments. Thanks for watching. Hope you had a great time and we'll see you soon.